All right, happy St. Patrick's Day. I'm going to mark this out. Today is Wednesday, not Thursday, 3/17. All right, so we're going to look over some general things, nothing really new with notes, but just kind of look and refine some information. So we have a couple rules with roots. So if you recall, the degree of a polynomial tells you the number of roots. So if I have a polynomial that is x to the 7th power, I'm going to have 7 solutions, 7 roots. Now, you can have real or imaginary solutions from any polynomial function, but if you have imaginary roots, they're going to come in pairs. So imaginary roots are going to come from using the quadratic formula or from square rooting. So like if I had x squared is equal to -4, this is going to give me 2 solutions. I need to square root the -4 and I get a positive 2i and a negative 2i. So if I'm square rooting something that's negative, you're going to get 2 imaginary solutions. If I'm using the quadratic formula, let's say I get something like 2 plus or minus 2i root 3 all over 2. I can simplify my fraction. So this 2 needs to reduce with my 2 coefficients in the numerator. So I have 1 plus or minus 1i root 3 over 1. But this gives me 2 solutions. I have 1 plus I root 3 and I have 1 minus I root 3. So if you have imaginary solutions, they either came from the quadratic formula or square rooting, and you have to have 2 of them. They have to come in pairs. So you will never have 1 imaginary solution. You always have its counterpart. So just a couple things to think about. Like if I have an even degree, I can have 2 real solutions. That would look something like this. If I have an even degree, I can have 2 imaginary solutions. That would look something like this. So imaginaries have solutions. I still have degree 2, but my graph does not touch the x-axis. I could have degree 6 and have 4 real and 2 imaginary solutions. So it might look something like this. 1, 2, 3, 4, 5, 6. So it touches the x-axis 4 times, but I still have degree 6. I could have degree 4 and have 2 real and 2 imaginary. So I could do 1, 2, 3, 4. I can think about that one. 2 real, and then my still has degree 4, so my other 2 have to be imaginary. I could have 2 real and 4 imaginary. So I could have 1, 2, 3, 4, 5, 6 total for the degree. And then the same is true when I have my odd functions. So if I have an odd function, I could have 1 real and 2 imaginary. So 1, 2, 3. I could have 3 real and 2 imaginary. So it's going to be 5 total. So 1, 2, 3, 4, 5. Right, so having imaginary solutions, you have to have 2 that go in pairs, and it's going to represent an up and a down, but not touching the x-axis. All right, so factors of a polynomial. So just a, my printers look like I need some new ink cartridge. Couple things. So if I have a factor, then the remainder after doing synthetic division, after doing my division, is going to be 0. So if you do synthetic division with some number here, right, and my remainder is 0, then this is a root. That's what we talked about yesterday. If this is not 0, then this is not a root. And if this is a root, then x minus that number is a factor, right? So we talked about yesterday. So yesterday we talked about a polynomial function. I don't remember what the function was, but we did synthetic division, dividing by x plus 2. So I had a -2 in here. We had numbers out here. And my remainder came out to be -36. If you recall, when we graphed this, it did not touch the x-axis at -2. It actually did touch at 1. But I had some point down here of -2, -30. Oh, so sorry, I can't see that. -2, -36. So we looked it up on the table. So a big point in polynomial functions when you do synthetic division and you get a remainder that's not 0, that's going to be the y value. So this being the x value, when I solved it out, got a remainder of the y value. So a point on this graph is -2, -36. If it's not a polynomial, if it's not a factor, it doesn't matter what happens here, but the remainder will give you a value. So we did this a long time ago, Algebra 1, where I would find f of -2. I would plug in -2 into my polynomial function. So my x value is -2. I did stuff. And when I simplify this out, I got -36. So f of -2 in this polynomial function is going to be -36. This is what I input. This is what I output. So we always output the remainder. So I can find if something is a factor by plugging it in. So if I wanted to check, let me find a good problem to do here. So, goodness, it's super loud in the hallway. Is x plus 1 a factor of 3x to the 4th minus 10x cubed minus 24x squared minus 6x plus 5. Is this a factor? I can tell you yes or no without doing synthetic division now. So with synthetic division, I would put -1 in the box, and then all my coefficients, 3, -10, -24, -6, 5, because I'm not missing anything. And I would look for my remainder. I'm going to show you another way. I can take this with -1, and I can find f of -1 by plugging in -1 for all of these individual x values. So let me do that. So 3 times -1 to the 4th minus 10 times -1 to the 3rd minus 24 times -1 squared minus 6 times -1 plus 5. I'm looking to get 0. So f of -1, -1 to the 4th is a positive 1. That's going to be 3. Minus 10, -1 to the 3rd is going to be a -1. So that's going to be a -10 times a -1, use parentheses, which will be a positive 10. Minus 24, -1 squared will be a positive 1, so minus 24. Then -6 times -1 will be a positive 6, and then a positive 5. So 3 and 10, that's 13. 6 and 5, that's 11. 13 and 11, so this is 24 minus 24. And f of -1 is 0. So yes, x plus 1 is a factor. So you can do synthetic division to check to see if something is a factor, or you can plug in that value that you would put in the box in doing synthetic division into the x values of the function. If you get 0, that would be your remainder, meaning that it is a factor. All right, and then, so you're going to do some of these in your homework for tonight. And then I also have some generic graphs. So these are super easy, hard problems. Maybe they're hard, easy problems. They don't require a lot of calculations, but we do have to do some thinking. So I want to sketch a polynomial function. I don't really have any questions to ask. But I'm sketching the polynomial function. So I know what my end behavior is. I know what my degree is, and I know if I have real or imaginary solutions. So my end behavior is x approaches -infinity, that's on the left. I'm going to go down. As x approaches positive infinity, that's on the right. I'm going to go down as well. All right, so I need an even degree. Good thing it's 6, because they're going to match up. So all my zeros are real, which means that I need to touch the x-axis 6 times. So I'm going to go up and down 6 times until I hit the x-axis 6 times, and finish it down here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 6 real solutions, degree 6. How high or how low this goes doesn't really matter, but my end behavior does, and the fact that it touches the x-axis all the time. Looking at this example, for my end behavior, the right-hand side goes up, and the left-hand side goes up. So it should have an even degree. Good thing it does. It's 4. 2 zeros are real and 2 are imaginary. So I need to go up, down 4 times. 2 times touching the x-axis with my up, down. 2 times not touching the x-axis. So 1, 2, 3, 4. This is not the only way to do it. I could also have 1, 2, 3, 4. Or I could have 1, 2, 3, 4. So all 3 of these would work because they all have degree 4. They all have the same end behavior, both sides pointing up, and they all touch the x-axis 2 times, but still have a degree 4, leaving 2 imaginary solutions. All right, got some homework to work on. Message me with questions.